Good afternoon and welcome everyone. My name is Marlieke Wijnakker and I'm co-owner of VormVrij, a Dutch company that provides 3D clay printers to educational and research facilities, just as ceramists and designers, fab labs and other institutions across the world. And we started out experimenting with an altered plastic printer just at home with some old clay. And because it worked, we decided to take it from there and see where it would lead us. So first we went to a workshop, then to a larger one, and now we work at a small factory building where I keep testing the performance of our printer, and together with my partner, we keep pushing boundaries by improving this technique. Sorry. Yes. But today I'll focus on architectural elements and architectural elements because they are quite difficult to make, these repetitive and detailed structures, to make them by hand or by slip casting or other traditional techniques. They are quite difficult, and I will show you why. So I'll talk about producing ceramics by hand, by slip casting, and with a 3D printer. And I'll not include the potter's wheel, because with the potter's wheel, the circular objects that you are able to throw do not really have that many possibilities for architectural elements to be implemented. So I'll leave that out of the equation today. When creating ceramic objects by hand, you really need a lot of expertise, skills, and time, especially for these small, intricate, and repetitive details. You can use wooden, metal, or plastic tools, but the most important tools are always your hands. So this also means that the limitations of this technique are your expertise and your craftsmanship, as well as the material you use, which is clay. Even though this artist was probably able to make even thinner pillars there, they would not have been able to hold the structure. So those are kind of the boundaries that you have when creating these objects by hand. Hey, sorry, not very used to this technology. When looking at contemporary functional ceramics, you see they are mostly quite clean. And by clean, I mean smooth surfaces without many time-consuming intricate details. And that is also because a lot of them are currently made with slip casting. And slip casting, I don't know who is familiar with this technique, is an interesting technique to use when you want to make multiple, how do you call it, exactly the same, identical pieces. And you need an original model, which can still be made by hand, from which you make a plaster mold. And into this plaster mold, you pour liquid clay. You allow it to dry to form a cast, and then the mold has to be able to release the cast. So sometimes it has to consist of many different parts. But even if you increase the number of parts, you will still not be able to implement all the architectural archetypes that we know, because it has to be able to release the shape. So there are, again, limitations. When you use 3D clay printing, a very diverse and endless amount of ceramics can be created. And of course, everyone already knows how a plastic printer works. It's about the same, but the raw material is clay, natural clay. This means that you have no waste, because if I am not happy with a print, I can just add water and reuse it again. And from like toothpaste viscosity to very tough cookie dough, depending on the size and the design I'm going to print. And when the printer is ready, is finished, you can still continue by hand. The clay can still be manipulated, or after bisque fire, you can add glaze. Because just like the touch of an artist's fingertip, it has a very distinct handwriting. It has, because it builds layer by layer, you will always see the horizontal lines unless you touch or glaze them. And during the design process, you have to keep the gravity in mind. So again, not everything is possible also with 3D clay printing when it concerns architectural elements and archetypes. But sometimes you can bypass the gravity by printing upside down or using support structures like these, which can easily be removed when the clay is leather hard. Or sometimes, if you need even more structures, you can cut them away after. This lamp is unique. We like to make unique things because that's one of the forces of this tool. But even if we were asked to recreate it, it would still be slightly different because of the characteristics of the clay we use. And because we don't need a mold, and it's very easy to adjust the design or parts of it, it is more interesting to create 20 different pieces rather than 20 the same. So perhaps a gradually evolving shape from one archetype to the other is a possibility. Is this a replacement for the traditional techniques? No. When a ceramist works with his hands to create a piece, he has a very personal signature. His work is very strongly kenmerken. It has specific characteristics which cannot be imitated by the printer. But he can choose to use this tool to build the basic structure, which is normally very time-consuming to have the measurements correct, and then continue by hand to for additional details or again to apply the personal touch, like this. Sometimes artists want to have big monumental work scaled down to be able to sell it in museum shops. So then a 3D scanner comes in handy after printing, and then continuing by hand, the artist just a finishing touch so that it is his signature work that is presented in the shop. When using slip casting, one mold can only produce one specific object. So if you want to make a collection or a wide variety of objects, you need a vast amount of molds and storage for all these molds. If you were to use 3D printer, you wouldn't need this warehouse full of molds. You would just have your memory stick with all your designs on it, and you would only print them when you need them. So the 3D printer does not replace the traditional techniques, but it is an additional tool which can be used and which allows customization, fast production of unique pieces, and it provides flexibility to the ceramic production process. When using additive manufacturing, you can create structural and visual components that are a totally new array. But one of the best, how do you call it, voordelen, benefits is that also the ceramic craft becomes accessible for people without the requirements of all the traditional skills that you would normally need. So, for instance, an architect can easily use this tool to make a scale model or building elements or interior designs. And someone with even a totally different background who starts using this tool will be able to make high quality architectural ceramics. I'm a designer, but I was never taught how to work with clay. I learned what the best viscosities were for each kind of print and also how to post-process them, just as I learned how to work with a 3D printer by trial and error. And sometimes a consciously designed outer structure will result in a beautiful, unexpected inner surface or vice versa. And these are like presents from the printer. So I will keep continuing to experiment and push boundaries with this technique. And I call myself and my partner and others like us, digital ceramists. Oops, that went too fast. If I would have used only my hands or a multi-layered, multi-parted mold, I would not have been able to create this chapel. It's a fictional model, yes, but it does show the possibilities of merging architectural elements and ceramic objects. And if you would like to see it, we are at the glass hall, where you're welcome also for additional questions, because I've now only focused on architectural elements, but of course there are a lot of other applications you can use this tool for which I've also brought some samples with me. Thank you for your attention, and maybe see you next time. Bye.
Thank you, Marlieke. Very interesting. So what's in your suitcase here? What can we see here?
Totally different things. So I do not focus on the glaze myself, but I have an example of what the structure would look like if you were to glaze it. So you can play with the fact where will I still see the layers, or where won't I see the layers. Probably a lot of people know this saber tooth from Thingiverse, and it was printed without any support structures. Only the fangs we did by hand because it was faster. And you can also think about filter applications. So we are not as precise as the really technical ceramics here, but still, well, I can't show you, but you can look through it. It's nice, and it's a good quality also for filtering, etc., etc. So you can just come up if you would like to feel the material. And
we're all going to give you a visit in the glass hall. Thank you for your little presentation.
You're welcome.
Have a wonderful exhibition. Thank you, thank you, thank you.
You're very welcome. Goodbye.